This lesson is over section 1.2, linear measure. We have two objectives today. The first one will be to calculate line segment length, and the second will be to write and solve algebraic equations using betweenness of points. First, let's talk about what is a line segment. A line segment is a line that has two endpoints and can be measured. This is different than just a regular line that we already learned about, because a line goes on infinitely and we can't measure it. But a line segment is just a segment of that line, so it can be. So to find the length of any line segment, we can always use our resources such as a ruler. What you will need to focus on whenever you are measuring different line segments is that you're using the correct units and reading your rulers correctly. So we can calculate the length of this segment in two different ways. We can either do centimeters or inches. For centimeters, this is going to be 3.2 centimeters. Remember that centimeters are in base 10, so each of these little lines counts as 1. If I was going to measure this in inches, it would be 1 1/4 inches. Now let's talk about congruent segments. Segments with the same length are congruent segments. This symbol right here is the congruent symbol, and you will see that throughout the rest of the year. So, is segment AB congruent to segment BC? If so, why? So here we are given AB and here is BC. How can we figure out if they're congruent? Just do the math. AB is going to be 5 because 8 minus 3 is 5, and BC is going to be 5 because 13 minus 8 is 5. Since they are the same length, they are congruent. Notice if you just look at the picture, it's not going to seem like they are congruent. Do not rely on how the picture looks. Always pay attention to the notation or any measurements that are marked. So notation is really important whenever we're talking about segments and their length. Down here we have the segment AB is congruent to segment BC. Notice how it is red. Next, we have the length of segment AB is equal to the length of segment BC. So if you're talking about just the line segment, make sure you have the line going over the top of AB and over the top of BC. When we're talking about the measure of that segment, we take away the lines and our congruent symbol turns into an equal symbol. Now let's talk about adding and subtracting segments. To add and subtract segments, we are going to use the betweenness of points. You can find the length of a segment by adding together the two smaller segments. So here we have the segment AC. We can find the length of AC if we were given the length of AB and given the length of BC. We could add the two smaller parts together to get the big part. So here's our first example. Find the length of AC. Now I know that this is a very basic example, but I recommend always writing out the betweenness of points equation. So we're going to add together our two smaller parts and set it equal to our bigger part. Then we are going to replace our letters by what they actually equal. So AB is equal to 13, BC is equal to 6, and we don't know what AC is. Then we add our two numbers together to get that AC is equal to 19. Next example, find the length of AB if AC is equal to 22. Now we're missing one of our smaller parts. We're still going to write out our betweenness of points equation, fill in the pieces that you know, And then all we have to do is subtract 10 over to figure out what AB is equal to. So AB is equal to 12. Here are some more examples. Remember to always try the examples on your own. So pause the video and try both of these. Then play the video to see if you did it correctly. This is a really good studying tip. So the first one, if DF is equal to 50, find the value of X. So now we're throwing in some variables, and this is why it's going to be so important to always write that betweenness of points equation first. So we add together our two smaller segments to equal our larger segment. DE plus EF is equal to DF. Then we replace everything with what we know. We know that DE is 2x minus 8, that EF is 3x minus 2, and that DF is 50. Now that you have an equation, we need to find X. So we're going to combine our like terms on the left-hand side. Then we need to add over the 10. And finally divide by 5 to get that X is equal to 12. Second example, solve for C and YZ if Y is between X and Z. So down here it gives you that XY is equal to 11, YZ is equal to 4C, and XZ is equal to 83. If you are not given a picture, you should always draw a picture first. This will help you now and definitely help you in the future whenever we get to the harder topics in geometry. So I'm going to draw my line segment XZ, where Y is between X and Z. I'm going to fill in that XY is 11, YZ is 4C, and I know the whole thing is equal to 83. Now I can visualize it, and I can write my betweenness of points equation. I can then replace with what I know. And now I'm just simply solving the equation for C. So we subtract 11 from both sides, and then we need to divide by 4. Now notice in my answer I have C is equal to 18, but it also asks for the measure of YZ. In order to find YZ, you just need to plug the 18 back in for C, and that will give you the measure of YZ, which is 72. We're going to go through a few examples. Make sure that you're pausing it, trying it on your own, then restarting the video to see if you got the correct answer. Find the length of AB, segment AB. Well, it can't be 2 millimeters because millimeters are smaller than a centimeter. Each one of these lines stands for a millimeter. So 2 millimeters is right here. If it's not 2 millimeters, it's also not 1.8 millimeters. Let's look at 18 millimeters. Well, here's 10, and then there's 8 more. So our answer is going to be C. Find the length of ON. This is going to be 2 centimeters. Find the length of AZ. The answer to this is going to be 1.5 inches. Find BD. Assume that the figure is not drawn to scale. Well, you're going to add together your two smaller pieces to get your bigger piece. Your answer is going to be 67.2. Thanks guys for watching. See you later.